Let's study the methods of solving quadratic equations. Methods of solving quadratic equations are factorization method, completing square method, formula method. Let us look at the factorization method. We have already learnt how to factorize polynomials. In this section, the method of factorization will be applied to solve quadratic equation. Before we actually solve quadratic equation, we state the following important properties. If the product of two numbers is 0, then at least one of them must be 0. Now, if ax square plus bx plus c is equal to 0 be the given quadratic equation, we must find two linear factors of a quadratic polynomial ax square plus bx plus c. Suppose px plus q and mx plus n are the linear factors of ax square plus bx plus c, where p, q, m, n are real numbers. Ax square plus bx plus c is equal to px plus q into mx plus n. The given equation ax square plus bx plus c is equal to 0 can be written as px plus q into mx plus n is equal to 0. Therefore, px plus q is equal to 0 or mx plus n is equal to 0. Therefore, px is equal to minus q or mx is equal to minus n. Therefore, x is equal to minus q upon p or x is equal to minus n upon m. Therefore, x is equal to minus q upon p or x is equal to minus n upon m are the roots of the given quadratic equation. Let us look at the examples. Example 1. Solve the quadratic equation x square plus 8x plus 15 is equal to 0 by the method of factorization. Solution. X square plus 8x plus 15 is equal to 0. We need to write the quadratic expression on LHS in the form of product of two linear factors. Split the middle term 8x as 3x plus 5x. X square plus 3x plus 5x plus 15 is equal to 0. Therefore, x into x plus 3 plus 5 into x plus 3 is equal to 0. Therefore, x plus 3 into x plus 5 is equal to 0. Therefore, x plus 3 is equal to 0 or x plus 5 is equal to 0. Therefore, x is equal to minus 3 or x is equal to minus 5. Example 2. Solve the quadratic equation x square minus 5x minus 36 is equal to 0 by the method of factorization. Solution. X square minus 5x minus 36 is equal to 0. Split the middle term minus 5x as minus 9x plus 4x. X square minus 9x plus 4x minus 36 is equal to 0. Therefore, x into x minus 9 plus 4 into x minus 9 is equal to 0. Therefore, x minus 9 into x plus 4 is equal to 0. Therefore, x minus 9 is equal to 0 or x plus 4 is equal to 0. Therefore, x is equal to 9 or x is equal to minus 4. Let us solve exercise 2.3. Solve the quadratic equations by the method of factorization. Number 1. X square minus 5x plus 6 is equal to 0. Solution. X square minus 3x minus 2x plus 6 is equal to 0. Therefore, x into x minus 3 minus 2 into x minus 3 is equal to 0. Therefore, x minus 3 into x minus 2 is equal to 0. Therefore, x minus 3 is equal to 0 or x minus 2 is equal to 0. Therefore, x is equal to 3 or x is equal to 2. Number 2. 3x square minus 10x plus 8 is equal to 0. Solution: 3x square minus 6x minus 4x plus 8 is equal to 0. Therefore, 3x into x minus 2 minus 4 into x minus 2 is equal to 0. Therefore, x minus 2 into 3x minus 4 is equal to 0. Therefore, x minus 2 is equal to 0 or 3x minus 4 is equal to 0. Therefore, x is equal to 2 or x is equal to 4 upon 3. Number 3. X into 2x plus 3 is equal to 35. Solution: 2x square plus 3x is equal to 35. 2x square plus 10x minus 7x minus 35 is equal to 0. Therefore, 2x into x plus 5 minus 7 into x plus 5 is equal to 0. Therefore, x plus 5 into 2x minus 7 is equal to 0. Therefore, x plus 5 is equal to 0 or 2x minus 7 is equal to 0. Therefore, x is equal to minus 5 or x is equal to 7 upon 2. Number 4. X square minus 3 root 3x plus 6 is equal to 0. Solution: x square minus 2 root 3x minus root 3x plus 6 is equal to 0. Therefore, x into x minus 2 root 3 minus root 3 into x minus 2 root 3 is equal to 0. X minus 2 root 3 into x minus root 3 is equal to 0. X minus 2 root 3 is equal to 0 or x minus root 3 is equal to 0. Therefore, x is equal to 2 root 3 or x is equal to root 3. Let us now look at the completing square method. Now see the equation x square plus 6x minus 2 is equal to 0. It can be written as x square plus 6x plus 9 minus 9 minus 2 is equal to 0. What have we done here? We have added and subtracted 9. What is the purpose of doing this? By doing this, underlying trinomial becomes a perfect square of x plus 3. So, we get x plus 3 whole square minus 11 is equal to 0. Means x plus 3 square minus root 11 square is equal to 0. In fact, we are converting a quadratic equation in the form x plus a whole square minus b square is equal to 0 to find its root easily. Let us correlate the above concept with the area of rectangle and square. We can see how x square plus 6x is being converted into x plus 3 whole square minus 9. X plus 3 into x plus 3x is equal to x plus 3 into x plus 3x plus 3 square minus 3 square is equal to x plus 3 square minus 3 square. X square plus 6x minus 2 is equal to 0. Therefore, x plus 6 upon 2 whole square minus 6 upon 2 square minus 2 is equal to 0. Therefore, x plus 3 whole square minus 9 minus 2 is equal to 0. Therefore, x plus 3 square minus 11 is equal to 0. Therefore, x plus 3 plus root 11 into x plus 3 minus root 11 is equal to 0. Therefore, x plus 3 plus root 11 is equal to 0 or x plus 3 minus root 11 is equal to 0. Therefore, x is equal to minus 3 minus root 11 or x is equal to minus 3 plus root 11. Therefore, minus 3 plus root 11 and minus 3 minus root 11 are the roots of the equation. So, x square plus 6x minus 2 is equal to 0 is written as x plus 3 whole square minus 11 is equal to 0 by process of completing square. This is known as method of completing square. In brief, x square plus 6x is equal to x plus 6 upon 2 whole square minus 6 upon 2 whole square is equal to x plus 3 whole square minus 9. So, x square plus 6x minus 2 is equal to x plus 6 upon 2 whole square minus 9 minus 2 is equal to x plus 3 whole square minus 11. If we want to solve the equation x square minus 6x minus 2 is equal to 0, then we can write LHS as x square minus 6x minus 2 is equal to x minus 6 upon 2 whole square minus 9 minus 2 is equal to x minus 6 upon 2 whole square minus 11. Alternatively, we can complete the square by finding the third term by formula as follows. The given quadratic equation is written as x square plus 6x is equal to 2. Let us call it as statement 1. Third term is equal to 1 upon 2 coefficient x whole square is equal to 1 upon 2 into 6 whole square is equal to 3 square is equal to 9. Adding 9 to both the sides of 1, we get x square plus 6x plus 9 is equal to 9 plus 2. Therefore, x plus 3 whole square is equal to 11. Therefore, x plus 3 whole square is equal to root 11 square. Taking square roots of both sides, x plus 3 is equal to plus or minus root 11. Therefore, x plus 3 is equal to root 11 or x plus 3 is equal to minus root 11. Therefore, x is equal to minus 3 plus root 11 or x is equal to minus 3 minus root 11. Therefore, minus 3 plus root 11 and minus 3 minus root 11 are the roots of the equation. Let us look at the examples. Example 1. Solve the quadratic equation x square plus 8x plus 15 is equal to 0 by the method of completing square. Solution. We have x square plus 8x plus 15 is equal to 0. X square plus 8x is equal to minus 15. We make LHS a perfect square by using 1 upon 2 into coefficient of x. The whole square is equal to 1 upon 2 into 8. The whole square is equal to 16. Adding 16 to both sides, we get x square plus 8x plus 16 is equal to minus 15 plus 16. Therefore, x square plus 2 into 4x plus 16 is equal to 1. Therefore, x plus 4, the whole square, is equal to 1 square. Therefore, x plus 4 is equal to plus or minus 1. Therefore, x is equal to minus 4 plus 1 or x is equal to minus 4 minus 1. Therefore, x is equal to minus 3 or x is equal to minus 5. Therefore, minus 3 and minus 5 are the roots of the given quadratic equation. Example 2. Solve the quadratic equation m square minus 2m minus 1 is equal to 0 by the method of completing square. Solution. We have m square minus 2m minus 1 is equal to 0. M square minus 2m is equal to 1. We make LHS a perfect square by using 1 upon 2 into coefficient of x. The whole square is equal to 1 upon 2 into minus 2. The whole square is equal to 1. Adding 1 to both sides, we get m square minus 2m plus 1 is equal to 1 plus 1. M square minus 2 into 1m plus 1 is equal to 1 plus 1. M minus 1, the whole square, is equal to root 2 square. M minus 1 is equal to plus or minus root 2. Therefore, m is equal to 1 plus root 2 or m is equal to 1 minus root 2. Therefore, 1 plus root 2 and 1 minus root 2 are the roots of the given quadratic equation. Let us solve exercise 2.4. Solve the following quadratic equations by completing square. Number 1. X square plus 8x plus 9 is equal to 0. Solution. We have x square plus 8x plus 9 is equal to 0. Therefore, x square plus 8x is equal to minus 9. We make LHS a perfect square by using 1 upon 2 into coefficient of x. The whole square is equal to 1 upon 2 into 8. The whole square is equal to 16. Adding 16 to both sides, we get x square plus 8x plus 16 is equal to minus 9 plus 16. X square plus 2 into 4x plus 16 is equal to 7. X plus 4, the whole square, is equal to root 7 square. X plus 4 is equal to plus or minus root 7. X is equal to minus 4 plus root 7x or x is equal to minus 4 minus root 7. Therefore, minus 4 plus root 7 and minus 4 minus root 7 are the roots of the given quadratic equation. Number 2. M square minus 3m minus 1 is equal to 0. Solution. We have m square minus 3m minus 1 is equal to 0. M square minus 3m is equal to 1. We make LHS a perfect square by using 1 upon 2 into coefficient of x. The whole square is equal to 1 upon 2 into minus 3. The whole square is equal to 9 upon 4. Adding 9 upon 4 to both sides, we get m square minus 3m plus 9 upon 4 is equal to 1 plus 9 upon 4. Multiplying both sides by 4, we get 4m square minus 12m plus 9 is equal to 4 plus 9. 4m square minus 12m plus 9 is equal to 13. 2m minus 3 whole square is equal to root 13 square. 2m minus 3 is equal to plus or minus root 13. M is equal to 3 plus root 13 whole upon 2 or m is equal to 3 minus root 13 whole upon 2. Therefore, 3 plus root 13 whole upon 2 or 3 minus root 13 whole upon 2 are the roots of the given quadratic equation. Number 3. X into x minus 1 is equal to 1. Solution. X square minus x is equal to 1. We make LHS a perfect square by using 1 upon 2 into coefficient of x. The whole square is equal to 1 upon 2 into minus 1. The whole square is equal to 1 upon 4. Adding 1 upon 4 to both sides, we get x square minus x plus 1 upon 4 is equal to 1 plus 1 upon 4. Multiplying both sides by 4, we get 4x square minus 4x plus 1 is equal to 4 plus 1. 4x square minus 4x plus 1 is equal to 5. 4x square minus 2 into 2x plus 1 is equal to 5. 2x minus 1 whole square is equal to root 5 square. 2x minus 1 is equal to plus or minus root 5. Therefore, x is equal to 1 plus root 5 whole upon 2, or x is equal to 1 minus root 5 whole upon 2.